Today's DMT Insight is on rethinking the teaching of area and perimeter. Why do so many kids have the same errors year after year mixing up area and perimeter? So we're going to talk about it's not the student, it's actually how we teach area and perimeter. So let's break it down. There's 4 misconceptions and errors that students have. The first error is students are mixing up. So when we think about area and perimeter of a rectangle, we'll usually teach that as the area equals length times width, and perimeter equals 2 times the quantity, length plus width. So when we teach that procedurally, those 2 procedures seem pretty close together, so they mix those up. The second thing that happens is then when we have composite shapes. So composite shapes, they're figures that are built from different geometric shapes. So a rectangle and a square and a circle, a triangle, and you have to decompose those different shapes to get at the area. And so students mix those up all the time, and they don't know what the procedure is. They're like, what is the formula? And so then they just make up different formulas all the time. The third one is that they think that when area increases, the perimeter increases, or if the perimeter increases, the area will increase. And that's not true. We'll talk about that a little bit later. And the fourth one is the use of tools. So we tend to use one type of shape, like a square tile, or sometimes a cube, to measure area and perimeter at the same time. That's very problematic. So what happens is, so imagine a rectangle, and we are measuring the area inside with square units with the tile. But then when they use this for perimeter, they start putting this around the perimeter. That's how it's taught. This is very, very common. I see this everywhere. And what happens is we're assuming that they're going to use the edge, but they're using this as, no, this tool is going to go all the way around. And so then each vertice, you have a miscount of 4 extra because they're not understanding the difference between linear and square units. Okay, so one thing, when we talk about perimeter is just the linear units that go around the boundary of any type of shape. So not just focusing on a rectangle. So we should talk about that globally first. And then when we talk about area, we're talking about the surface and having how many square units fit inside or iterated inside that boundary. So to really get at that as we teach, one of the first things I want to do with teaching any type of shape is I want to talk about the 4 dimensions. Okay, so we're going to start with 0 dimensions. So what I do with kids is, so we start this very young. We talk about all 4 dimensions first. So what is 0 dimensions? So I'll ask kids, okay, so put your finger up in the air. There's a little point right there. That's 0 dimensions. What do you measure with 0 dimensions? Nothing. So that's really important. Now we're going to take that 0 dimension, and then we are going to take it to another point, and we could just continue forever. And now we have, and kids will be like, a line. That is 1 dimension. So now, what do we measure with a line? We can use centimeters, inches, miles. And at that point, we're going to move to a really important idea is then what are the tools we're going to use? We are not going to use a cube. Sometimes I see kids trying to use cubes, the little edge there, to measure the perimeter. We're actually going to use something that is linear. So if we're using non-standard units, I like using coffee stir sticks. And you can break them off into a non-standard unit, or you could cut them so that they are a centimeter or an inch or whatever you want to use, and then use this initially. So then they get that manipulative to feel, and they can iterate it around the boundary of the shape. That's really critical. Okay, we go back to now 2 dimensions. So now we take that 1 dimension, that line, and we're going to go down with it. So now we've created this surface. The surface to measure here, we have square units. Now we're going to use something like a tile or grid paper, but we'll initially use tile, and we can see how many square units this surface measures. Then I'll also go into 3D. So now we take that surface area here, and we can either pull it forward or pull it back, and now we have this volume. So with volume, now we're going to use a cube to measure how many cubic units it takes to fill that volume. So now we have 3 specific tools, and we've talked about 0 dimensions we don't use, 1 dimension we have linear units, 2 dimensions area, 3 dimensions and square units, 3 dimensions cubic units. That is really critical. So now we can move into talking about teaching perimeter. What is perimeter? Perimeter is the boundary. Oh yeah, what dimension is that in? That's 1 dimension. Oh, what are our tools? We're going to grab the stir stick or a toothpick or a string or something and measure around the boundaries. critical. Okay, now we're going to teach area. Oh yeah, area is that surface. Now we need square units. We're going to use the tile, we're going to use grid paper, and then we move into the formula. And then same thing would be for cubic. After we've done perimeter by itself, area by itself, now we can mix area and perimeter together and talk about the two. And I would do that with square and rectangular shapes first. Then we're going to start moving to composite shapes. So now we can have rectangular shapes. We can add in triangles, we can add in circles, and we can start decomposing those different shapes. So that is really an important idea there. So now we've built that idea of the difference between 1 dimension and 2 dimensions, perimeter and area. We've gone into the different composite shapes. Now we can start looking for patterns, because this is one of the other errors. What happens if you hold area at 24 and you look at all the different shapes? So you could do a 2 by 12, a 3 by 8, a 4 by 6. The area is staying the same, it's constant, but what's happening to the perimeter? So when the area is more of a long, skinny rectangle, the perimeter is much larger. As it starts to form closer to a square, then the perimeter decreases. Now, what happens if you held the perimeter at 24? You would have a 1 by 11, a 2 by 10. And as the perimeter stays the same, what happens to the area? The area starts to increase each time. So looking for those patterns. So just a quick recap. So making sure we use the correct language. We talk about the different dimensions. We use the correct tools first. We separate and teach linear units before area, before volume. Then we can start bringing them together. When we teach this way, then area and perimeter are not confusing. So as we finish up this DMT insight, we've got 3 others that are really important that tie in. One of them is focusing on conceptual understanding. When you focus on the concept of area and perimeter first, then go into the procedures, that's so important. So check out our DMT insight there. Another one is on Jerome Bruner's enactive, the physical models tools, moving to iconic, visual, to then the symbolic. That's critical as well. And then the third one is spatial reasoning. How important it is for kids to examine these different shapes and compare and look for patterns. So check out those 3 DMT insights for more valuable information. So hopefully you like this one, you like those others. Follow us, like us, and share this with other people.